Sri Nanambika Degree College, Autonomous, Madanpalli. It is my great honor and privilege to welcome you all to the inauguration of our faculty development program. Excuse me. It is my great honor and privilege to welcome you all to the inauguration of our faculty development program on the transformative role of AI in urban development, healthcare advancements and engineering emerging industries. Organized by Department of Computer Science, Sri Nanambika Degree College, Autonomous, Madanpalli from July 7th through 12th, 2025. We are living in a time where artificial intelligence is reshaping not just industries, but human experiences across every sector: urban planning, medical diagnostics, manufacturing, finance, and more. Through this FDP, we aim to explore these evolving dimensions and equip our faculty with interdisciplinary AI knowledge, hands-on skills, and industry-aligned perspectives. This program is unique in design. Over the next 6 days, participants will engage with distinguished speakers and industry experts, delve into technical sessions, participate in article discussions, hands-on training, and even an industrial visit, ensuring a comprehensive learning experience. I take this opportunity to thank AICTE-ATAL Academy for selecting our institution to host this program and for their continued vision in faculty empowerment across the nation. Once again, I welcome you all and look forward to a successful and enriching FDP ahead. I also take this opportunity to warmly welcome Principal Madam Ramadevi Garu, who has always been a guiding light in all our initiatives. A special welcome to our dynamic and visionary leader, our respected correspondent sir, R. Guru Prasad Garu, for his constant support and encouragement in all our academic endeavors. I extend my heartfelt gratitude to Dr. Kumaira Kalam Garu, who has been working as a professor and BOS State Person, Department of Computer Science and Engineering, Sri Venkateshwara University, Tirupati. I extend my heartfelt gratitude to our chief guest, Dr. Mahendran Garu, Assistant Professor, Department of Computer Science and Engineering, IIT, Tirupati, for gracing this occasion with your esteemed presence. We are truly privileged to have you with us today, sir. Before we begin, I request all our dignitaries to join us for the lighting of lamp symbolizing the light of knowledge and innovation. I request our chief guest,
Venkatesham Smarami Smarami Hare Venkatesa Prasida Prasida Priyam Venkatesa Prayascha Prayascha
for lighting the lamp and inaugurating the session with such grace and positivity. Now I request our beloved principal ma'am, S. Ramadevi Garu, to address the gathering and share her thoughts.
Respected dignitaries on the dais, and faculty members of Sri Jnanambika Degree College Autonomous, and other college faculty members, research scholars, postgraduate students, good morning everybody. We have gathered here today to participate in the faculty development program sponsored by AICTE Training and Learning Academy, ATAL, and organized by Sri Jnanambika Degree College Autonomous. This often FDP focuses on various thrust areas and emerging fields. ATAL is conducting faculty development programs to enhance the knowledge and skills of faculty members, postgraduate students, research scholars, and industry professionals also. Teacher is also an eternal student, you know very well, isn't it? Teacher is also an eternal student. Nitya Vidyarthi teacher kuda everyday చదవాల్సిందే, everyday prepare అవ్వాల్సిందే, update అవ్వాల్సింది కూడా. So faculty development programs are crucial for enhancing the quality of education and ensuring faculty members are equipped with the latest knowledge and skills. They play a vital role in improving teaching methodologies, fostering research, and creating a positive learning environment. I am extremely delighted that such a wonderful program was conducted in our institution today. Thank you very much.
Thank you so much, ma'am, for your valuable words and encouragement. Your constant support always motivates us to take up new initiatives and raise academic standards. Now, I would like to invite our respected correspondent, R. Guru Prasad Garu, whose visionary guidance and dedication continue to strengthen our institution's growth and values.
Good morning. Today's chief guest of this August gathering, Dr. Mahendran from Indian Institute of Technology, Tirupati, and the eminent personality in the Department of Computer Science, Sri Venkateshwara University, Professor Humera Khanum, Principal of this institution, and faculty of this institution, and faculty from other institutions who came all the way for this August gathering, and the students of various colleges. Good morning to each and everyone. And my special thanks to the management and principals of other colleges who encouraged you to come all over here to participate in this event. Nowadays, the scenario of technology is changing. There is many more advancements in the technology. To facilitate the faculty in such a way that AICTE came forward with the scheme of ATAL. It is very, very essential for the faculty development program to offer numerous advantages among the members of the faculty and also for the students. Why mainly faculty development programs are conducting by AICTE? To improve the teaching skills. We are going for various colleges and listening to the professors for their expertise in each and every subject, so that you can change your attitude and you can change your teaching and methodology for the students who are the stakeholders of this program. And also for the faculty, professionally will grow, because we studied in olden days, there is no such facilities, there is no such technology. If you visualize, if you listen to the eminent personalities and their endeavors, you can easily communicate to your students. And also the faculty members for participating in such type of FDPs, you will have global contacts or state contacts, and you can mingle with other faculty members. Then you can discuss what is happening in the global scenario regarding to pertaining to the technology. This is very, very important for the students and faculty members and also the researchers. Now, if we are having reading of newspapers, today also in the Andhra paper, AI to Nindu 150 ఏళ్ళు. Say AI is working out for the efficiency and large volumes of data. Say it is going to replace the human in future days. Now everybody is talking about quantum technology, which is one more advancement. There is a lot of changes in the technological world. So that my dear faculty members and my dear students, it is a platform to learn more about the technology, and the facilitators will facilitate you for the 6 days. You can go through and listen to the resource persons who are invited by our institutions. I wish everybody will go through it, and fruitfully these sections will end up with the 6th day. Wish you all the best. God bless you all.
Thank you, sir, for your inspiring words and continuous support for faculty development and innovation. Now it is time to introduce the most awaited guest of the day, of our chief guest, who has graciously accepted our invitation to inaugurate and enrich today's FDP. It is an honor to introduce our chief guest, Dr. V. Mahendran. He is an assistant professor in the Department of CSE, IIT Tirupati. He completed his PhD in area of delayed tolerant networks from CSE Department of IIT Madras. He did postdoctoral research from School of Computer Science between 2013 to 2016, University of Oklahoma, USA, and worked as visiting assistant professor at Department of Computer Science and Software Engineering, Miami University, Ohio, USA, for a year before joining IIT Tirupati in academic year of 2017. His research interests include wireless networks, ML for IoT, reinforcement learning, and federated learning. We are truly privileged to have such a distinguished personality with us today. Now I request our honorable chief guest to kindly address the gathering and begin the FDP keynote.
Good morning, everyone. So before we start with the topic of the FDP, let me thank the host institute, Sri Nanavika College, Autonomous, Correspondent Garu, Principal Ma'am, and the coordinator, and the faculty, management and staff members of the institute. And then the last, I welcome everyone, the audience who wanted to kind of interact with us in the faculty development program.
Sir, you have PPT. Yes, sir.
Yeah. So the topic of this, I think this ATAL's FDP is a very good program. I hope not just information overloading the audience, rather it is about, there is a program that runs that magically classifies an image from dog or a cat, right? So that mystery we have to break it in this FDP. Okay. So AML program is also a computer program which doesn't run on a special server. It is also running on your very same laptop and mobile phone. But what is so special in the programs, we call it as AA and ML. In fact, at the end of the session, I think you will be assured that AML program is also a normal C program that you run. Like your addition and subtraction program in your usual programming laboratories that do. It's the same kind of program, right? So what is the usual programming language that you use? For any one of you who have used AML, taught AML before, what's the predominant programming language? C, C++, Java, Python, what was that?
Python.
Python, right? So it's the same programming language that you use. But the question is why? What is so special about a particular set of programs which we call it as machine learning, right? There are other programs we never call it as a subject area, right? It is just because they are so popular we call it as a special program. No, there is a fundamental difference between machine learning program and other traditional programs. Okay, so once we understand the perspective, it is easy to see what is happening nowadays and easy to catch on with the resource materials. So, so the focus of my thing is you should understand first what is a machine learning and how is it different from the traditional program. Okay, so how many of you know how many varieties of machine learning programs that are there? How many machine learning? What are the three pillars of machine learning?
Supervised, unsupervised, reinforcement.
Great, right? So there are three pillars, right? What is supervised learning?
Supervised learning is a training. First of all, train the data.
Right.
After I will one new image and new data is
Testing phase.
yes.
In fact, supervised and unsupervised both has test training and testing.
No, both are same, but unsupervised is a unlabeled data.
Okay. So this is the key thing where many of us get kind of confused. So I want to give a clarity about that. Right? So supervised learning is like a supervision, right? So the data is labeled. Okay. So which means you have a data and then what is the label of the data? You have a bunch of cat images and then you label them as cat. You have a bunch of dog images, you label them as dog. Right? So once you feed this labeled data into the system and it trains to learn the features that connects the cat and among all the set of cat images, what are the features that map to the cat? Likewise, the program that learns, okay, the features and then later when you supply a new test sample, it can able to identify whether it is a cat or a dog. And what is unsupervised learning?
Unlabeled data.
Right. Okay, what do you learn in an unlabeled data?
This is K-means clustering.
No, I am not asking example. What is an unlabeled? In unlabeled data, what is that you learn?
This is the Flipkart data is unlabeled data. This is software algorithm are using.
Okay, so the question is like not the example. Like supervised we gave, right? It's a labeled data you learn to connect your label with the data. Right? What is that you're learning in a unsupervised?
So qualitative and quantitative.
Sorry. There is some pattern hidden inside the data. We don't know what the pattern is. We are not supervising that this is the pattern you identify. Let the program do identify its own pattern. This is the most confusing part of the machine learning and much more advanced one is reinforcement. So I want to give a clarity right now. Shall we do an unsupervised machine learning program right now? Imagine that you are the computers running machine learning. You are doing an unsupervised learning. Shall we try to play a game where we understand what unsupervised learning is? So here is a task that I am going to give you. I am going to think something in my mind. I will be revealing you a sequence of numbers. Okay? You are going to tell what is the concept that I am thinking. Okay? So the rules of the game is this. I can tell you any number between 1 and 100. Okay? Integers. Any number I will say. Okay? And it need not be a sequence. It comes from a bag of some, these numbers come from some concept. You have to guess what I am thinking. Let's say if I say number 2. What is that you think that I am thinking?
Even.
Yeah.
Even.
Right? So let's go with this flow. You understand the rules? I will tell you any numbers. I will reveal a number one by one. And you have to tell what is the concept that I am thinking. The first number is 4. What is that I am thinking? Yeah. Somebody said square and somebody said even numbers. Is there any other concept that you think in your mind?
Multiple of two.
Right? Then anything else?
Could also be checkerboard now.
Right. Right. Okay. Now, I am revealing the second number from the same concept, 64.
8
Square.
Sorry?
8 square.
I said 2, right? 8 square will not match.
2 power 4.
Powers of 2,
Yes.
right? Okay, now 16. See, you should say whichever concept that should match with all of the numbers I said. I said 2, 64 and then 16. Whatever you say should match all the numbers, right? It should not like match with every number. Then you are doing random thought. I have told reveal 3 numbers, right? 64, then 16 and then 2. There is nothing wrong in being wrong, right? We are just learning. What is the concept?
Powers.
Powers of 2. Is there any other concept that I am thinking in my head? That powers of 2, multiples of 2 are the same. Even numbers?
Yes.
Right? Whatever I said is even, right? 2, 64, 16 is even number. So, okay, fine. What I was thinking is powers of 2. Right? So, now I have some data that I revealed. You guessed what is the concept I was thinking in my head, right? This is unsupervised learning, as simple as it is. Right? So, every data that comes, I have some function in my mind. Using that function, I am revealing some numbers arbitrarily matching the function. You are identifying the concept. This is the very basic for unsupervised learning. Right? I did not tell you what is that I am learning, you just identified. But we did not solve one problem. What was that? There are 2 concepts that was matching with this number I said, right? One is even numbers match to 16, 64. Powers of 2 matches to 16, 64. Even machine learning can also come to this confusion, right? 2 or more concepts, patterns will match the same data set. Now, I ask you this question. If you were to choose one output, what is that you choose? Powers of 2 or even numbers?
Even numbers.
So, how many of you will do even numbers? Raise your hands. Okay, how many of you will go for powers of 2? I see a 50-50 chances, but you have to take one call which is highly probably correct. Which one?
Even numbers.
Powers of 2 or even?
16.
So powers of 2 is the right one. The reason being is, what is probability? Favorable outcome by total outcome. If I take a number between 1 and 100, how many numbers are there even? A lot of numbers, right? So probability of getting 16, 2 and 64 by total number of given numbers is relatively less than to getting 2, 16, 64 by than the powers of 2. So the denominator is lesser, right? So the probability of getting powers, that the number that I generated from powers of 2 is higher than generating the same number from even numbers. So this is another thing that your machine learning has to do. Which one is highly probable? That is the one that it outputs, right? So this is a very simple example of unsupervised learning, and k-means clustering, whatever you said comes as an example of that. Okay. Another confusion that people will have is AI and ML. What is AI? What is ML? People may kind of use these terms interchangeably nowadays, but actually there is a clear-cut thing that is there. AI is a field. Okay, what do you mean by AI? It's an acronym for artificial intelligence. Whatever humans we think, if there is a computer that mimics that thought, you call it as artificial intelligence. A subset of a subfield of AI, you call it as machine learning. It is a bunch of algorithms, okay, that learns, identifies pattern from the given data. Okay. Now coming back to the very fundamental question, what is the difference between a Python program that adds 2 numbers and there is a Python program that classifies 2 images? What's the difference? Can anyone? Both are C programs. They run on the same laptop that you have. One you call it as a traditional program, non-machine learning. The other one you call it as a machine learning program. What is so special? The game that we played just now, right? You can use that as an example. Now you can differentiate a machine learning from a non-machine learning program. What is that? See, when I said 2, somebody said powers of 2, somebody said even numbers, somebody used some other concepts. But I was revealing more and more numbers. Can you see that you are converging to fewer and fewer patterns? Is that correct? So when I said 64 and then 16, many of you have converged to only 2 concepts, 64 and powers of 2 and even numbers. Why is that so? Because machine learning program has a special property that if you pass more experience, if you pass more data, the performance, the output becomes more and more accurate. This is not the way with the traditional program. If I pass 2 numbers in an addition program, it has to give me an exact result. It is not that the performance improves when you pass more and more numbers, then it will give a correct answer. Because traditional program, you pass a rule, it will work the rule, apply it on the data, give you a processed data. But machine learning program is the same computer program, but the outcome of the program improves better and better as you pass more data. That's the difference between machine learning and non-machine learning programs. Hope you get the fundamental difference here. Okay? You can feel free to interrupt me anywhere you would like. And so there are many applications nowadays. Why is machine learning so popular nowadays? Can anyone have thought about it? When I did my computer science, I never expected machine learning will become more popular, but now it is so popular. Why is that so? Because this is something that we cannot stop. The reason is, if you see the history, we started with, let's say, industrial revolution, where we have machineries, industries coming up, making the human task easier. Then later came the information revolution, where computers have started and all the mundane tasks have been replaced by the computers. Now what is happening nowadays? Everybody has how many computers in your place? You have a mobile phone, which is a computer, right? Your smart TV is a computer. You have a desktop, you have a laptop. So a single person is having so many computers. So imagine billions and billions of people around the planet using computers. What is that they will end up with? What is that these computers throw out? Data, right? Once the data are there prevalently available and you have machineries that manages, processes and stores data, the next thing that we move on in the information revolution is finding some patterns from the data. Okay? And that is where artificial intelligence and machine learning is again becoming popular, because you have in the information revolution a lot of machineries and computing devices and technical advancements to capture the data, that now you wanted to process and store only the information, not the data. And that is why machine learning is becoming popular. Okay? So I'm not going into the applications of all those things, because we have very good eminent resource persons who will talk about machine learning and applications in a variety of areas. But to name some of them, like you have security and privacy issues, AML can be used there to kind of automatically detect spam from non-spam attacks and things like that. And nowadays you know that ChatGPT has become very famous, right? So many companies, services companies use chatbot, which actually uses generative AI under the hood to run the show. Okay, and I think we discussed this before. The 3 pillars of machine learning, which is supervised and unsupervised, which I have acronym here. I have not talked about the last pillar of machine learning, reinforcement learning. Can someone tell me the difference between reinforcement learning with respect to the other 2 pillars, supervised and unsupervised? I guess now you know what's the difference between supervised and unsupervised. Now, what is reinforcement learning? How is it positioned across these 3 tracks? Yeah, supervised learning will also perform tasks. The question is, what is the key difference? Okay, I have given you one example which you can carry forward, which you will never forget. Supervised and unsupervised learning is learning by seeing YouTube lectures. What are the problems and advantage of supervised learning from YouTube lecture? Say you are watching a lecture on AML. right? It's on YouTube, there is no interaction. You watch the video, what's the drawback? You're trying to learn the concept as the instructor is speaking something on the YouTube video. Suddenly you had a question, right? Is there a way to ask? No.
One-way communication.
It's one way, there is no interaction. Supervised learning, unsupervised learning is like one way. You have a bunch of data set, you feed to your program, you train it, there is no feedback loop. So it doesn't matter whether your program learns or not, your data set is not going to vary. Of course, you are dividing the data set into training, testing and all sorts of things. But the data set that you have is the only data set that you have. You cannot change according, for example, let's say I have a machine learning program. I am passing a bunch of dog images, cat images. Now suddenly, the machine learning program got a kind of confusion whether this nose feature, how this nose feature of the image is not clear. Can it ask the programmer, can you send more image of a cat so that the nose part is very clear? You cannot do so. There is no feedback, right? Whatever image you have, you pass it. More the image, better, like a machine learning program. But your machine learning program, whether it learns or not, is independent of your data set. This is not the way human beings learn from our childhood, right? What is our usual learning from the childhood? We go to schools, we go to colleges, right? What is the difference between physical learning and classroom learning? In classroom learning, you get to interact. An instructor comes to your class, instructs some talk, and in the middle of the talk, you get a question. What do? You ask a question. Then the instructor will respond to your question. What do you mean by that? The data set is changed based on the questions you ask. If you ask a good question, the instructor will give you a good data. You train well. If you ask a dumb question, instructor will not give you a good data. You will not learn. So the performance of your training depends on the questions that you ask, how you interact. This is one difference between supervised and unsupervised and reinforcement learning. And the other thing is you learn sequentially, right? And have you seen this kind of reinforcement learning in anywhere in your physical activities? Where there is an environment, you interact, environment will teach you something, then you learn and you better yourself, you master your activity in the environment. Have you anyone, can you connect this with a real world activity?
Humanoid robotics.
Sorry?
Humanoid robotics.
I am not asking the real example of the reinforcement learning. Is there some activity that you learn in your real world as you grow up which mimics the reinforcement learning?
Everything is a classroom, a family, teaching children about aspects. This everything comes under reinforcement learning.
Right, sir. But I am asking some other activity other than classroom. Classroom I have given
Video
example.
games. Gamification.
How many of you know driving cycle? How many of you know driving two-wheeler? How many of you know swimming? Right? So did you learn swimming by doing or by reading the manual of swimming? By doing. Right? So how do you learn?
Stimulation.
Right? So first you go to the swimming pool, you do some practice, and what is the environment? Who is the RL agent? You are the RL agent. The environment is a swimming pool. First you do some strokes, then you get drowned. And what do you mean by that? By doing some strokes, you are interacting with the environment. And the environment is giving you feedback in the form of what? When you drown in the pool, the environment is punishing you. Environment is penalizing you, right? Now what you do? You don't do that action. Then you try a different stroke. Now your body is afloat on the water. Now you interacted with a different action. Your environment gave you a positive reward, which is you are afloat. You are happy. Then what you do? You repeat the one which makes you happy. Then you don't stop there. You do some other strokes to improvise. Your body will be afloat and you kind of float on the water. Right? You move. So environment is giving more reward as you do an action. So what is this loop? As an RL agent, you interact with the environment, and this action is not good. The environment punishes you, penalizes you, gives a feedback. When you do something that is good, environment gives you happiness, you will feel afloat. then you get a positive reward. So you do run an optimization problem. What is the optimization problem? Given you are in particular state, you do an action, environment rewards you or penalizes you. You learn the actions that are better for you to do the task. That is reinforcement learning. So swimming is you learn through a concept from reinforcement learning. And this year 2025, you know what is the equivalent award in computer science that is equivalent to Nobel Prize? Anyone of you? Which award is equivalent to Nobel Prize in computer science? Have you heard of Turing Award? Turing Award is equivalent to Nobel Prize in computer science community. And 2025, Turing Award went to whom? He was one of the pioneers in reinforcement learning, right? So go check that. I think it's Richard Sutton and his supervisor. So they got the Turing Award for 2025, which is a very famous Nobel Prize equivalent. Okay, and take it from me, reinforcement learning will be the next hot topic in the machine learning, and supervised and unsupervised kind of people will use it as a kind of formula. Okay, because things are changing very dynamically, and we are into generative AI, reinforcement learning, and quantum computing. It is time for you to learn into new tracks of machine learning and artificial intelligence. Okay, so reinforcement learning is something like a classroom learning where you have an environment, you react. To be very precise, you ask questions, you get good data. You ask bad questions, you will not get good data, right? So that is reinforcement learning for you. Okay. So if you understand the basics of all these things, three things, I think you can learn any algorithm that is out there and apply to any field of applications that you have. Any questions? I hope you have a fundamental clarity into the science of supervised, unsupervised, and reinforcement learning. If you are clear with this, I think machine learning is a kind of piece of cake. Okay. So this is the applications of ML in healthcare. As I said, the perspective is more important than the information that is there, because you have a lot of equipment, drugs that are coming in. Now you wanted to do a lot of classification, predictive analytics, diagnosis, prognosis, things like that. Again, you can apply all the pattern recognition algorithms in machine learning. So I am not getting into the details of it because the entire week FDP program focuses on that. Okay. Right. So I want to end up with one final thing. We did one unsupervised learning, right? I will do one classification problem, which is supervised learning. So what you see here is some training data set. Okay. How many labels are here? This is a binary classification or a ternary classification? How many colors are there?
3 colors.
3 colors, right? Binary means 2 colors. You have to classify 2 labels. There are 3 labels. And what is here is, I have 3 colors of labels, red, blue, green. And what you see is, on the center there is an X mark. I want to know which class this X mark belongs to. Okay? How many of you say that X mark belongs to red? Please raise your hands. Do you see the X mark in the center, last row? How many of you say that belongs to red? Okay. How many of you say that belongs to blue? How many of you say that belongs to green? Fine. So the majority voting is for red. Okay. So what is the machine learning algorithm that you ran in your mind? How do you say that was red?
Regression.
No jargons. Just the concept. Like, wow. What was the logic that you applied? What was the logic that you applied to say that that is red? Your answer is correct, but how do you apply?
Green and blue. Green and blue are mixed rather than red.
Yeah, you are correct, sir. Yeah. So the logic is very simple. We have divided the whole image into grids, right? And in the neighborhood of that X, the grid that where X lies, how many red points are there? Many red points compared to red and green. Green and blue. So what is the algorithm that sir said is majority rule? You divide the whole space into multiple grids, right? And then wherever the test sample is sitting, you see what is the majority color that is there. So you run a simple algorithm, which is a majority algorithm. Wherever the test sample sits, take the grid, count the number of colors, each color count you take, majority color count, you associate that cross to that color. That's how you do the classification. Of course, this is not a very good algorithm, but this gives a basis for what are the things that you should take care of while doing machine learning algorithm. Okay, this is not the perfect machine learning algorithm classification, but it is one good learning algorithm. Okay, what is the problem? Can you pinpoint one problem with this algorithm? What will be the problem? You look at this picture.
There are some green dots also there.
Yeah, I'm using majority rule, right, sir? So there could be one color that is majority. If multiple colors will have the same number, I will break randomly the tie. I have a functional logic, but what could be the drawback? I think the whole image gives you a hint. Do you see? Sorry? And that's why the majority rule breaks it, right? Red is 1 and green is, green is 1.5, say 1 is there, blue nothing is there, red so many are there. I selected red, correct. But what is the drawback? What if the cross point sits on an empty grid? Your algorithm works fine, but if your test sample sits on a grid somewhere on the left top or the right top, your algorithm will not work. Why? You don't have data samples to classify. Your majority rule will not work. You see a problem? This is where convolution, neural networks uses convolution process. Okay? Now how do you fix it? Don't say convolution. I want a simple intuition to fix it. How do you fix it? Okay, you need to know what is the problem in order to fix it. What is the problem? I have a lot of empty spaces. I want to reduce the empty space. What is that I am going to do? One thing is, yes sir. Sorry? No, you are not able to move. But there should be some systematic way to move. You know high dimension to low dimensional projections? When you project a points from a high dimensional space to low dimension, what is going to happen? The empty space area is going to decrease. Okay? Okay, so this is another problem. I will come to that. You see, here the points are spread into two-dimensional space. What you see on the right? I drew a line and then I projected all the two-dimensional points on a one-dimensional point. Do you see there are a lot of white space in the 2D space? And you see the white space is very less in one dimension. So this is where whenever you study embedding or projecting points into the lower dimension, you never thought why convolution is done, why you are projecting to the low dimension, because the empty spaces reduce. Your majority algorithm will work better in low dimensional than in the high dimensional. Is that clear? Okay. And can someone tell you what is this algorithm? The converter, PCA, right? Principal component analysis, right? You can find a place where the variance is higher and then draw a low dimensional subspace, project it, right? So the key point I wanted to take is, don't see the algorithm and say, okay, I have this algorithm, I run it, I get the result. That everybody can do. Try to understand the science behind the algorithm. Machine learning will be a very interesting topic and you can easily master everything in the machine learning. Okay? So that's the key idea. I hope you understood the basic science behind supervised, unsupervised and reinforcement learning. So with that, I think, thank you very much and have a great FDP program ahead. You have a lot of information to learn. I hope you have at least learned a little bit of perspective of machine learning from me. Okay, thank you very much and all the best for your FDP.
Thank you so much, sir, for your inspired and insightful address. We are truly grateful for your presence and valuable contribution to this inauguration. Now, we move on to the technical session, which marks the beginning of the learning journey of this FDP. To make the session forward, we are honored to have with us our esteemed resource person for the day. It is my pleasure to introduce Dr. M. Himayra Garu, who has been working as a professor and BOS chairperson, Department of Computer Science and Engineering, Sri Venkateswara University, Tirupati, Andhra Pradesh. She has 26 years of teaching experience. Her qualifications are BTech, MTech and PhD. Dr. Himayra Garu was awarded a PhD in Computer Science and Engineering from Sri Venkateswara University, Tirupati. Her areas of interest include artificial intelligence, machine learning, speech and learning, language processing, human-computer interaction, and big data. She published several papers in reputed national and international journals with high impact factor. She attended several national and international conferences and presented papers. She conducted and attended several workshops and training programs. She was a resource person for AICTE sponsored seminars, workshops, and conferences. She delivered invited talks at several conferences and guided several BTech and MTech projects, and had a number of PhD scholars working under her guidance. She is an IEEE member, a life member of ISTE, a member of the editorial board of IJNLC, and a life member of SPU WTA. She published 3 books. She received the State Best Professor Award for University Education from the Honorable Chief Minister of AP. On September 5, 2022, she received a National Award for Teaching Excellence. The award was presented to her in the Computer Science and Engineering category at the Indo-American Education Summit and Expo 2013. She received an Outstanding Faculty Award. The award was presented in the Computer Science and Engineering category of the Venus International Faculty Award 2016 from the Venus International Foundation on July 9 in Chennai. She received the Women Researcher Award in 2022. She is a BOS member in Computer Science and Engineering, a Nodal Officer for Microsoft's upcoming skills, and a BOS member at several engineering colleges. She served as Nodal Officer of the National Academic Depository, Flying Officer in the NCC, Deputy Warden, PG, NBA and NAC Coordinator. Now, I humbly hand over the session to our respected resource person, Dr. M. Himayra Garu, to begin the first technical session of this session.
Thank you for your nice introduction. Respected chairperson of this Jnanambika Degree College, Sri Guru Prasad sir, principal, vice principal, and today's guest, Dr. Mahendran from IIT Tirupati, faculty members, and organizers, and delegates who came from different colleges. Very good morning to one and all. Let me congratulate the entire team of Jnanambika Degree College for having this wonderful workshop on transformative role of AI in urban development, medical advancement and industries. It's a wonderful topic, and I thank the AICTE for this good initiatives. This type of workshop, number of faculty members got benefited through this type of workshop, and will be get benefiting because this is a wonderful workshop. ATAL is organizing so many workshops under this AICTE. Now actually, artificial intelligence is one of the very good topic which changed the entire world around us. Artificial intelligence, the name itself indicates it is not a natural. Whatever the intelligence we have, that is a natural. So the simple definition for this artificial intelligence is nothing but putting human intelligence into the mission. Sir have given a very good content regarding this machine learning, types of machine learning with good examples. And I will start my section with basic fundamentals. What is it? What are the different types of applications have been developed as so far? What is the basic principle behind that one? Artificial intelligence is not a single area. It is a broad area in computer science and it is an interdisciplinary area. We need to know about computer science, psychology, philosophy, mathematics, and neuroscience, and then only we can develop a good application in AI. So under this AI, so many areas comes under this AI. Machine learning is one of the area. The speaker spoke about excellent machine learning concepts behind that: supervised, unsupervised, and reinforcement learning. In this AI, there is image processing is there, speech recognition, speech synthesis, pattern recognition, deep learning, expert system, robotics. All these comes under AI. AI is one of the broad area in computer science and engineering. So because of lack of time, I don't want to extend my lecture. I will take first section after this one. Here I conclude my speech. I would like to thank the organizers and chairperson of Gnanambika Degree College, madam and sirs. Thank you for giving me this opportunity to share this, to share my knowledge, whatever the knowledge I have in this field with you, and I'm very thankful to you. Thank you for giving me this nice opportunity. Thank you one and all. Thank you. Let's start the next section after the tea break. Okay?